The purpose of today's lesson is to go over the 4 types of stoichiometric problems. We're going to go over them from simplest to most difficult. The simplest of the 4 types is the first type here, mole to mole. It has only one step. We're only going to use one equivalency, and the equivalency we're going to use is number 2. The number 2 I'm referring to is the one I'm circling here, that one. So let's do a problem like that. So here we have the mole to mole problem. Let's say that I have 14 moles of oxygen. And according to this chemical reaction, I'd like to know how many moles of carbon dioxide will be produced. I'll start with a given, 14 moles of oxygen. And I'm going to use what's called the mole ratio. The mole ratio is this equivalency here, blank moles of A equal blank moles of B. And because there's a mole on the left and a mole on the right, when I make a fraction out of it, I'm going to have a mole on the bottom, and I'm going to also have a mole on the top. Now, the number that goes before those, that should be in blue, the number that goes before each of those is the coefficient that's in front of that particular substance in the balanced chemical reaction. That substance is oxygen, shown here, and there's a 2 in front of the oxygen. In front of the one in question, and the one in question here is the carbon dioxide, there is an implied 1. And so you'll see here that the moles of oxygen will cancel, and we'll have a new unit, which would be moles of CO2. Mathematically, we're going to take the 14 and we're going to divide by 2, which is 7. So 2 significant figures is 7.0. That's our answer. We should have been able to figure that out anyway, because according to the reaction, for every 2 moles of oxygen, I only get 1 mole of carbon dioxide. So if I start with 14, I would only anticipate 7 moles, according to the balanced chemical reaction. That's the simplest type, called a mole-to-mole problem. Well, let's bring it back here. Now I'd like to do the next more difficult type, most difficult type, and we're going to try the mole-to-mass problem. It's going to be 2 steps, and I'm going to use the same equivalency I just used, and then this first one, which I'll circle here. It's going to be 2 steps, so let's do one like that. Here's our mole to mass. Let's say that I had 14 moles of oxygen that we had before, and now I want to know how many grams of carbon dioxide will be produced. Well, we'll start with a given, which is 14 moles of O2. And I know it's going to be a 2-step problem. Let's go back up to my boxes. You see it's a 2-step problem. And I'm going to use the mole ratio first. Now, the mole ratio, will, whenever we use it, will be mole on the bottom and mole on the top. What is the ratio between those 2? Well, according to the balanced chemical reaction, move it down here a little bit. According to the balanced chemical reaction, I have 2 moles of oxygen. And the reaction says I will have only 1 mole of carbon dioxide. So that's my first step. I'm changing colors to signify that I'm no longer talking about oxygen here. I'm now talking about carbon dioxide. So the next ratio I use, come back up here to our boxes. If I need to use number 1, I need to use the one right here. Yeah, 1 mole equals molar mass. I'm going to change it to grams now. So 1 mole of carbon dioxide, and I need to know the molar mass of carbon dioxide. Now, that would require me to add 12, which is carbon's molar mass, to 16, which is oxygen's molar mass. But since there's 2, I'm going to have to add 16 twice. And when you add those together, you get 44 grams of carbon dioxide. Now, mathematically, you would take 14 divided by 2, which is 7, and 7 times 44. 44 times 7 is 308. And that's my answer. So according to my equation, 14 moles of oxygen would yield 308 grams of carbon dioxide. The next type, we refer back to the box, is going to be our mass to mole. It's going to be very similar to the one we just did. It's also going to be 2 steps, but notice here, my 1 and my 2 are reversed. So I'm going to use the top one first, and then I'm going to use the second one. So let's go to the next type of problem. Mass to mole. Let's go to the methane this time. Let's say I have 36 grams of methane, and I'd like to know how many moles of oxygen will that require? How many moles of oxygen will that require? Let me erase a little bit here so I don't run into it. So let me write down the given, 36 grams methane. I know this is going to be 2 steps from the chart. I'm going to use 1 mole equals a molar mass first. And of course we're going to need grams on the bottom so that they cancel. I need the molar mass of methane. Well, carbon weighs 12 and each hydrogen weighs 1, and that is 16 grams. Now I'm going to use my mole ratio. And I'm going to change colors here once again to show that my compounds are changing. On the bottom is going to be my methane, and according to the balanced chemical reaction, there's 1 methane. And on top is going to be what I'm looking for in this problem. And what I'm looking for in this problem is oxygen. Now, how will we figure this out? We have to take 36 divided by 16 times 2. Well, 36 divided by 16 is a little over 2, and 2 times 2 is 4. So we're looking at something around 4. Let me take my calculator out to say for sure. So once again, 36 divided by 16 times 2. And yes, I get 4.5 moles of the O2. That's our answer. That is a mass to mole problem. Lastly, the most difficult problem, it's not super difficult, it's just the longest problem, I guess I would say, is my mass to mass problem. It is 3 steps, and it'll be a 1, 2, and a 1. Let's go to this last one. And let's say that I got 18 grams of water, and I want to know how many grams of oxygen did I start out with. So write down the given, 18 grams of water. We said from the chart this is a 3-step problem.
Please pardon this interruption. Shannon Flavin to Miss Aguirre's office. Shannon Flavin to Miss Aguirre's office.
We said this was a 3-step problem from the chart. The equal sign always goes at the end of the conversion factor. We're going to use number 1 first. The 1 mole of water over its molar mass. And you should have molar masses. The molar mass of water memorized. It's 18. The middle step is going to be the number 2 equivalency, which is the mole ratio. And on the bottom is going to be what we have. We have water, and there's a 2 for a coefficient in front of the water. The top is going to be what we're looking for. What we're looking for in this case is the oxygen. There's a 2 in front of the oxygen. In the last step, I'm going to use the number 1 equivalency again. 1 mole equals molar mass. This time, the 1 mole is going to go on the bottom. And the molar mass of oxygen, which is 32, will go on top. So mathematically, I'm going to take 18 divided by 18 times 2 divided by 2 times 32. And I think you can do the math pretty simply with me. That answer comes out to be 32. 32 grams of oxygen. That makes a lot of sense because 18 grams would be 1 mole of oxygen. And 1 mole of oxygen, because it's a 2-to-2 ratio, would give me 1 mole of water. And so that's how I would have gotten 18 grams of water, because that is its molar mass. Well, those are the 4 types of chemical reactions.